Good day! Welcome to the last part of Unit 2 measurement, and we're going to be talking about an interesting set of units, density. So density is a description of how much matter is crammed into how much space. When we think of stuff as being heavy or light, we're actually thinking density, because obviously you get a gigantic pillow the size of a car, it's going to be very heavy, but it's still fluffy. And you pick up a very dense rock, it might only weigh a couple of pounds, but oh, it's a heavy rock. Well, really, it's a dense rock. It's a bunch of metal. So for this, we're looking at how much matter, how much stuff is crammed into a certain amount of space. And we can do this for a couple of reasons. First off is identification. Certain things are going to have specific densities, or at least ranges of densities. The classic story, which is probably not true, but it's also too good not to tell, is that the ancient Greek polymath Archimedes was hanging out in his Greek city-state, and his king had recently been told that his brand new crown was a fraud. See, the problem was that he had given a bunch of gold to a goldsmith and told the goldsmith to make a crown, and the goldsmith did. But the courtiers were going to the king saying, the goldsmith embezzled you. That crown is only partially gold, but it's also lead. He sold the gold for a profit and swindled you out. You have a lead crown. Well, the king's got a problem. If the goldsmith really did this, he can't let someone embezzle from him. It'll show that he is weak, and everyone else will embezzle from him, and thus he is in trouble. So he must chop off the goldsmith's head if the goldsmith did it. However, if the goldsmith didn't do it, then it is clear that everyone will know that the king is easily manipulated. You can get the king to do anything you want. You just have to lie to him. And he can't be lied to. He's the king. He's got to take control of his kingdom. So he goes to Archimedes and tells him, hey, I got a problem. I need to know, did the goldsmith embezzle from me? Here's the deal. I will pay you a nice little pile of gold if you can tell me if the crown is real gold or if it is fake. And if you can't, well, I got to chop someone's head off. So, gold and keep your head. Just tell me which one it is. So Archimedes is like, well, it's a lot of money, and I really, really, really would like to not die. So Archimedes is like, I don't know how to do this. I don't know how to do this. I can weigh stuff. That's pretty easy. Now, keep in mind, this is ancient Greece. We've got no, laser X-ray fluorescent stuff. No. He's like, I can weigh stuff. That's really pretty easy to do. We've been weighing things for a long time. That is an important part of commerce. And if I knew the volume of the crown, then I could figure out the density. And if the density was the same as that of gold, I would be fine. However, oh boy, I can't just beat the crown into a cube or something. I can't find the volume of something so lumpy because, once again, I don't have laser assisted computer stuff. I'm in Greece in 600 BC, so no computer laser stuff. So Archimedes goes home. He's like, well, I guess I'll think on this one. And hops in his bath and notices his bathtub rises up. He goes, Eureka! And runs around screaming. Like, yay! I figured it out. The volume that the crown goes into water will displace the equal volume of water, and I can figure out the volumes of water. That'll work. And so he's able to figure out the identity of the crown. Is it gold or is it lead? The story doesn't say who got their head chopped off, so I don't know how to answer it. This doesn't rule out that it's not something weird. It doesn't prove that it's gold, but at least you know that it is possible that it's gold, or it could rule gold out as a possible choice. The next one that's important, not nearly so much for chemists, but for more physical folks, is buoyancy. Things that have a lower density will float in fluids that have a higher density. So if I take ice has a density of about 0.88 grams per milliliter, and water has a density pretty close to 1 gram per milliliter. So ice will float. In order to float, in order for buoyancy to work, you have to push out of the way an equal mass of liquid, whether it be water, air, or whatever, or gas, I should say, a fluid, compared to yourself. Now, if you're very dense, then you'll push away your volume and you'll just keep going down. But if you're light and fluffy, then you'll push out the volume of fluid and then you'll just float there. Yay. So this is relatively important for us. By the way, the Mizuku, an interesting topic you might want to check out. It's a rather unfortunate event where carbon dioxide gathers in depressions in the ground, and well, if you happen to go walk through the depression, you're not breathing air, you're breathing carbon dioxide. So, by the way, that is a link to a video. The actual link will be in the content description, and if you got the PowerPoints, that is a link. Now, what we use it as chemists the most for, though, is as a conversion factor. Density is a compound unit. It's a mass unit divided by a volume unit. In theory, it could be any old mass unit and any old volume unit. You could do slugs per acre foot if you'd like. That's an English unit of mass and a rather large unit of volume. But traditionally, we use grams per milliliter for solids and liquids. And since gases are fluffier, we usually use grams per liter. But anyways, it's going to be a mass unit divided by a volume unit. You've got a fraction that contains two different units. That itself is a conversion factor. So yay, we can use this as a conversion factor. And it's going to be particularly useful because mass we're going to use later on as part of our conversion to start counting atoms. So we can use density as a conversion factor. So, let's put a line there, just like, previously discussed. We'll do the line mole method. And you start out with whatever thing you know. So let's say I've got 2.5 milliliters of gold. Yay, I've got some gold. Well, then I use density and I can say, okay, if I know the volume of gold, gold's not sold by the milliliter, it's sold by the ounce, which I can get to from grams. So I go to the density of gold. Once again, what I want by what I got, and my milliliters of gold cancel. By the way, always leave not just the unit, but what is the unit of. So milliliters, that's nice. Milliliters of what? Water, gold, manure, Let that cancel out, and then I can do the math. I get 48.3 grams of gold. Round that to 48 grams because, I only had 2 sig figs to start with. Yay. Alternatively, I could go the other way. Let's say I had 3.2 grams of gold. I could use the density, but now, since I'm starting with grams, it's what I want by what I got. If I want milliliters, well, I put the milliliters on top. So I simply take the density. The number for the density is going to associate with the grams, whatever's on top of the fraction bar for the units. Well, now the top of the fraction bar for the units is on the bottom, so it's going to go on the bottom also. So now I'm going to divide. And boom. And I go ahead and round. Yay! And that's the story. So with that said, hope you enjoyed density, and I will see you next time when we jump into the atom.